Hello, everyone. So, this is part two for chapter four, and we will be talking about the first hop redundancy protocols. Actually, when it comes to this topic, this is somewhat deviated from the either channel. But since we are talking about redundancy, we have multiple lines of your connection from one switch to another switch. We are using multiple lines. That is from chapter 3. And also from chapter 3, that is known as the STP or the spanning tree protocol. And then the implementation for the either channel, wherein those multiple lines, multiple links from one switch to another switch or one switch to another router, we are now lumping it up and make it into a one group of links that will be uh, consolidated in order to have a maximum or a maximized bandwidth. That is in chapter 4 under the either channel. But also, part of the solution when it comes to scaling networks is that there should be redundancy. That is why we have multiple switches, multiple lines. And another thing also is this one, the first hop redundancy protocol. This is the name of this convention, this solution, but Cisco is using another term for that. That is the HSRP. Okay. But in the network discussion, this is known as the first hop redundancy protocol. Okay. And we have been in, or a lot of offices or a lot of uh, companies have been using this, or maybe you have this in other internet cafes, and I will explain the similarity of that when it comes to redundancy protocols. Okay, so to start, let's proceed to the discussion. Okay, so when it comes to the first hop redundancy protocol, we are just taking a look at let's take a look at this network. Okay, the connection from a switch to a multi-layer switch. This is one link. If you can follow my pointer, so this is one link. Another one is from this switch going to the first switch. This is designated as your routing switch because that is a multi-layer switch. So this is a designated line. And then also this switch is connected to another switch that is that makes it redundant. Okay? So even if this line will be cut off, this computer will be still be connected to the server. But the main limitation when it comes to switches is that it can hold only one default gateway. Okay? So there's the problem. It is not the same as routers wherein you can automatically route each of the connection whenever there is a change of the configuration or there are lines that have been broken because of some distortion to the network. Routers can do that. But when it comes to switches, it's not capable of doing that, not unless it is a multi-layer switch. Okay? So with this scenario, PC1 can connect to the server by using this router as its gateway because it needs a gateway. So if this router is present, then the line connecting here will allow this PC1 to connect to the server regardless of where it is going. But it really needs a gateway. Okay? That's the main limitation. So that means if this line is disconnected, there is no connection anymore. Okay? And I will be presenting a demonstration on that. That will be part 3 when it comes to this discussion. Okay, so that is the process of why we need to have a redundancy protocol for the first hop. By the way, first hop is a discussion or is a term that is known as the first router in your network. Okay, so if this is your computer and you are connecting to a, a computer or a server that is connected within the network, the first router that you encounter, that is what we call as the first hop. Okay, so first hop redundancy protocol just gives you a term when it comes to networking for redundant connection. But in other words, it is basically known as load balancing. Okay. Maybe you have heard about it, maybe not, but I hope I will be able to discuss it. I hope after the end of this discussion, you will be able to understand what is first hop redundancy protocol. Okay, so that is the problem. When it comes to this network, it is connected. When it is connected, this computer will be able to connect to the server. But if this line goes down, this computer will not be able to connect to the server, regardless of what happens. Okay, so that's it. So you can read about this, but I hope my explanation would allow you to understand better. So the next part, in order to establish the redundancy part, let's take a look at another illustration. As you can see here, you have two physical networks of two physical routers. This is the first router and the second router. Okay, so it may not be clear to you the names of this. This one is the active router that is known as the um, forwarding router, or the forwarding, that when we are talking about a forwarding router, that is your active router. The other one is your standby router. The standby router is your backup. So if in case this forwarding router goes down, your standby router will activate and will serve as your primary gateway. But in order to to make the shift, or to make the adjustment that will allow all of these computers to be connected to your ISP or your services, it needs to have a virtual router. So when we are talking about virtual, we know that the functionality is there, but it's not physically present. Okay, so a virtual router is a program within the network, within the routers, that will allow physical networks to automatically switch from one another in case of a problem. Okay? So that is what we call as redundancy. That is the redundancy protocol of it. So if you can see the connection, we only have two physical routers. This one and the other one. So this one is your standby. It is a ghost router. Okay, just like if you are familiar with the government and we have a ghost employee, you are, or that employee has been receiving salary even if it's not there. Okay, so similar to that one. So I'm just saying we only have two physical routers, and then this one is your virtual. This one manages the connections. Okay, so by doing that, it allows you to create a an automatic switching of your route. Okay, so even if this primary router goes down, you still have this router to manage the connection. Okay, so that's it, router redundancy. Now, what is the first hop? The first hop will allow you to, if this is your PC or a computer that is connecting to the surveys, it will use the forwarding router as its first hop. But if this is disconnected, it will use the other one. Okay, so first hop redundancy. As I have said, this protocol or this type of solution is better known as load balancing or uh, dual one. Okay, in other networking terms, it's known as dual one, dual wide area network. Okay, you maybe have two internet connection. Let's just say PLDT, globe lines, or you have four. Oh, PLDT, Converge, and then you have Starlink or whatever. So if in case the primary connection goes down, the secondary connection will go up as your primary. That's it. That's the solution. Okay, so you can read more on this presentation, but I hope my presentation is or my explanation suffice. So another on this part, the failover step. So that means if this primary router goes down, automatically the connection will need the virtual router will then switch from your primary connection and lead and enable or activate the secondary router or your standby router in order for it to connect. Now, please take note, you have an IP address of your router 1, you have an IP address of your router 2. All routers will not have the same IP. But and also an IP address of a virtual router will also be created. Just like your VLAN. We know it's there. We can create an IP address on that VLAN, but there is no physical connection. Okay? So here are the steps on how it will function, but it's like this. If router 1 and router 2 or the forwarding router and your standby router are active, your virtual router is connected to your router 1. Okay? So that's it. This is your active. So the line from your computers going to your internet or your ISP will go through the virtual router and passes through your forwarding router. Okay? This is the primary router. If this connection goes down or the router turns off, automatically your virtual router will now switch to the connection for your standby and allow it to become the active router or the new forwarding router. So that means all of the connections now will go through the virtual router and to the new forwarding router going to the internet. Simple as that. Okay. Notice that the IP address, if you can read here, the IP address and the MAC address will be the same. Okay. And the other presentation will allow you to understand it more. And the part 3 on my demonstration will give you the idea on how it is being created. Okay. So that's it. If the forwarding router, the active router goes down, the virtual router will allow the connection to be switched to the standby router and make it its active connection. Okay? And then, since Cisco is creating its own, that is why they call it the Hot Standby Router Protocol. That is known as the HSRP. But honestly, it is known as the First Hop Redundancy Protocol. For other networking devices other than Cisco, this is the name FHRP. Okay, the First Hop Redundancy Protocol. But since Cisco, a well-known networking company, they would always want to create their own. So that is known as the Hot Standby Router Protocol, HSRP. It has the same process. It uses the same protocol of the standby command. Okay. You can read more about it, but it's still the same. It has an HSRP for IPv4 and IPv6. Similar to other first hop redundancy protocol, there is IPv4 and IPv6. Okay. Of course, through the iteration of the devices, Cisco is most likely implementing, or with my discussion, and for the sake of our configuration, we will most likely be using, most of the time, we will use version 2. There is version 3, but it is safe to use version 2 for now. Okay. So the HSRP or the standby protocol, we will be using version 2. Okay. Just like your router RIP or the router information or routing information protocol, we have version 1, 2, and 3, but we are using version 2. Okay. Similar to this one, we have 1, 2, 3. We will be using version 2. Okay, because that is sitting at the most convenient spot wherein all of which are running without any problem, and it is supporting new devices. Okay, so here's the process. Let's just take a look at the standby protocol of the first hop redundancy protocol, or your, if you are strictly using Cisco, that is your uh, HSRP. Okay, so as I have said, you have two routers on this demonstration. We only have two routers, which means these computers will be connecting to the external routers by using either of these two routers. This one is a virtual device. It is created on the network, but it is not really physically present. Okay, take note, it needs to have its own IP address similar to the IP addresses of your routers. Okay, and then all of your IP addresses of each router will never be the same. It should be unique. Okay, so that's it. That's the configuration. So if this is the forwarding router, if it goes down, virtual router switches to router number 2. And if router number 1 goes up again, then this becomes the standby and automatically it switches to the active router. Okay. So um, you can read more about this one, but it's just saying that this is the most likely the IP address or the MAC address, and then we will be using the group numbers version 1. This is version 2. That is why version 2 is very active because it uses a lot of numbers. But for the sake of you understanding the network, we don't really need this one. Most of the time, we only use group 1 and group 2, or just two numbers. Okay. So the priority and the preempting, which means the process now is uh, if this is your forwarding router, it should have a priority more than 100 because the default HSRP will be 100. So if you are going to designate a router that is your active router, it should be more than 100 in designated priority number. Okay? You will see that later on the next slide. So, if we do preemption, this one is, if we are talking about R1 as your priority, we will have the priority number of this R1 more than 100. And then we will never set a priority number for R2. Okay? So, by doing that, if router number 1 is not available, this router number 2 will automatically be the preempted priority number 100. And that's it. Okay? In other networking protocols, most of the time, it will use the highest IP address on your network. That is also the reason why um, an IP address will have, example, the gateway will be 1. And then another IP address will be on the next or on the upper part of the spectrum, that is 254. Diba? So you already seen how I configure my gateways. Most of the time, it's either 254 or 1. Because in the creation of the network, the highest IP address would automatically be your default router and the default gateway. That is why I am using the 254 setup. So that's the reason. But when it comes to this one, HSRP, or the first hop router protocol, redundancy protocol, you can also use the preemption mode by just using a number above 100. And that's it. Okay. Take note, we are using the command standby. It's always the case. Standby and then standby version 2. Okay. Let's skip this one. Let's go to the setup. So the process when it comes to when you are creating the configuration, the first thing that you are going to do is to enable the configuration. So that is standby. Okay. So the keyword for creating HSRP or your first hop redundancy protocol is to enable the standby command. So type in the standby and then make it running version 2. Most of the time we will be using version 2. Okay. So most of the time we have standby version 2. So we are now using HSRP standby version 2. Okay. Now after that, we will create the group. As I have said, version 2 will have from 0 to 4095. But most of the time, we'll be using group 1, group 2, group 3. Just one number. Okay? And then create a priority number. So if it is your active router, it should be greater than 100. Okay? The active router should be greater than 100, and then you will not allow or you will not configure a priority number to your standby routers. And that's it. Okay? So the how you are going to issue. So for this example, router 1 is your active router, router 2 is your standby router. Okay? So enable your router 1 with the interface because you need the IP address. Okay, so we need the IP addresses of because of this one and this one. Now make sure that by doing the standby version 2, you already know or you already have an IP address of your interface. Okay, because we are talking about the gateway. Okay, so if you are using interface G01, this is G01. This is now a gateway of this computers. Okay, so 172.16.10.1, that is a gateway, and 10.3 is also a gateway address. So by using it in R1, okay, so standby version 2, standby group number 1, this is your group number. So group number 1 and your IP address is 10.1. This is your 10.1. This is how we create the virtual router. Okay? So take note, we are creating within your forwarding router, we are creating the virtual router and assign a new IP address of that. Notice we have 10.2 in router 1, 10.3 in router 2, and 10.1 in your virtual router. So, mind you, in Cisco, the highest IP address really doesn't matter because of the priority number. Okay? So standby, group number 1, assign it with an IP address. This is how you create your virtual router. Okay? And then creating the standby 1, that is group 1, priority 150, it is above 100. So that means it is your active router. And then create the preempt. So standby group 1 preempt. Meaning, if the system goes up, automatic this is your active router. And if this active router goes down, it will automatically elects the secondary router as its primary. Okay, so create the virtual router by using standby tapos your version. And then create the group, standby maybe group 1, 2, 3, 4, and then assign the IP address. Set the priority number greater than 100, and then use the preempt, and then make sure you are configuring no shutdown because, as I have said, we are using the interface. Now, moving on, if we have created the virtual router that is connecting to your forwarding router, we go to your second router and then configure the IP address, this part, okay? And then use standby version 2, similar to your router number 1. Also, create the standby with the same IP address pertaining to your virtual router, and then no shut. That's it. You have now created your virtual router. Okay? So, priority above 100, that allows your router, the highest number will be your active router. Okay? So, if ever it goes down or you want to monitor everything, show command under the enable mode, show standby, and you will see which router is running as active. If that router you are using the show standby, is it active or is it on standby? Okay. And then the show standby brief allows you to understand the summarized version of the information of your show standby. And you will see the state and the priority number. Okay? Since we did not create the priority number for router number 2, it is automatic priority 100. So I hope it's clear. And then after that, this is what we will be doing for part 3. So um going back with the discussion, um it's really a process of redundancy wherein we are now creating a gateway or a connection from these computers going to your external services or external networks by creating a redundant path. So the first path, if this is your priority, all of your connection will go through this and going to your external. Notice that there is no gateway from here. Okay. So by creating the standby routing protocols under the HSRP or your first hop router protocol, it allows your network to have more than one default gateway. Okay, more than one default gateway by just using a virtual router using the standby command. And that's it. So part 2 is done, and I hope you understand. If you do want to read more, I would want you to read the text that is highlighted on this presentation material. Okay? So that's about it for part 2. The demonstration will be posted tomorrow. That will allow you to understand this part. How are we going to create the virtual routing in this network setup? Okay, so that's it. Thank you very much. See you on the next session.